Welcome to Built by Insights, the show about building Colorado homes and the stories of how they're made. Today's guest is Enrico from Emu Passive. This is the second of 3 episodes with Enrico. Well, Enrico, what I'd like to talk about next is kind of the basic principles of passive. Sometimes from a builder's perspective, somebody who doesn't know much about energy, being efficient, building better, it can be daunting. And it's really not that daunting at all. If I was to say, Enrico, could you tell my wife why we should build passive and what that is, and explain it in a way that she would be excited about it? I'd love to hear your perspective on that.
So the simplest way to think about this is a Yeti cooler.
Okay.
And think of your drinks that stay cool. If they're inside the cooler, if they're warm, they stay warm because the environment is constant inside the cooler. The cooler is well insulated all around, and that is the first principle of passive house. That is, you have insulation, good insulation on your walls, on your floor, on your ceiling, and how much insulation depends on your climate. So you're going to have more insulation if you go up to the mountains. Or if you go down in milder climate zone, you're going to have less insulation. And that is something that somebody very smart does the calculation in the background. But at the end of the day, insulation is simpler than a heat pump. Or if you think of a fridge, that is a pretty simple piece of technology. Insulation is way simpler. It's your wool sweater. It's a house with a wool sweater.
Okay.
Now, you don't want to have any rips or any holes in your wool sweater, and those are thermal bridging. Thermal bridges are either areas that are poorly insulated, or if you have a steel beam that cuts through your insulation, steel is very conductive and brings in the cold from the outside, or in the summertime it brings in the heat. So the second principle of passive house is to avoid any thermal bridging through your sweater. You want to have that insulation being continuous and avoid any weak holes of the insulation that are the thermal bridges. Those are the first 2 principles. Then you want to avoid leaks of air for a number of reasons. Drafts makes the house uncomfortable. They also bring in pollution from the outside. And the more cold air comes in from the outside, the more your heating system has to work during the wintertime. And the more the cooling system, your AC, has to work during the summertime if you have the hot air coming in July. So the air seal or the airtightness is the third principle of passive house.
And that really gives you the control of the environment inside.
Exactly. That is your Yeti cooler. Now, we don't want to live inside a Yeti cooler because we want to get in and out without opening the lid. So we need a door.
Yeah.
And we want to have daylight, so we want to have windows. And windows, if you think about that, are the areas of the whole envelope where we have the least amount of insulation. So they are, in other words, the weakest link of this equation. And that's why for passive house, the fourth principle is to have windows and doors that are good enough to provide thermal comfort, which in the Boulder area, which is climate zone 5, equates to triple pane windows. But if you're in California, if you're in Texas, you can get to the same level of comfort with double pane window. Passive house is not a checklist. There's a lot of science that we do in the background to choose, because we want to be cost effective. You don't want to pay for something that you do not need. So passive house tells us what level of comfort we need, and that is the fourth principle of passive house. The fifth principle is we want to have fresh air inside the cooler. It can be stuffy, so we want to have a continuous supply of filtered fresh air.
We're building a clean room.
Correct. It's
Okay.
a clean room.
It is.
Exactly. So there is, in the first place, there is fresh air. So unlike a Forster system will recycle that air. If you have a lot of CO2, if you have a lot of odors inside your house, they will stay inside your house. Passive house wants to have fresh air from the outside so that you can get rid of odors, you can get rid of moisture, you can get fresh air. We want to filter it so you don't bring in pollution from the outside. So if there is pollution either from a city or if there is wildfire smoke outside or pollen, it gets filtered before it gets in. And the other side of this yin and yang is we have air sealed our Yeti cooler. So the pollution stays out and we have control over the quality of the air that comes in.
What happens if I leave my windows open?
You're in a passive house, you're going to be fine.
Okay.
You can open your window, you totally can. You will not need to. Like my parents are 75, they do live in a passive house. Each room have an operable window. They forget to open windows because they have that fresh air, not recirculation, the fresh air supply that provides them with fresh air.
Mm-hmm.
So that is very convenient, and the air quality is very high in the house.
On the fresh air systems in Colorado,
Mm-hmm.
we have a very dry climate.
Mm-hmm.
A lot of people, a lot of our, building in our homes, there's a lot of wood. So we're taking a lot of moisture out of the house.
Mm-hmm.
How do you properly control with your fresh air system and moisture introduction?
Mm-hmm. That's a great question. Something I did not mention yet is that in this air exchange, there is a part of the ventilation system that is called the ERV or HRV.
Mm-hmm.
That is the heat recovery ventilation, or in the version that is more suitable for dry climate as well as for very humid climate, it is called the ERV, that is the enthalpic recovery ventilation or energy recovery ventilation,
Mm-hmm.
which recovers the heat as well as the moisture.
Okay.
So it reintroduces the moisture without the two airflows mixing. So it helps preventing the house being too dry. A big part of that is also the building is airtight. We are used to buildings being very leaky.
Mm-hmm.
And the leakier the building, the more the moisture escapes, and it gets very dry here in Colorado.
Yeah. One of the builders that I started with when I was a kid, and Brian, our brother, worked for, built a lot of the early pioneer houses in Boulder.
Mm-hmm.
They were progressive because they were some of the first ones who started insulating the walls,
Okay.
right? I mean, when you go into some old homes in Boulder that we remodel still today, there's no insulation.
Mm-hmm.
Most of them have been retrofitted, but it wasn't the standard.
Yeah, it wasn't a thing.
So it was like very progressive to be like, wow, they're putting R9 insulation
Mm-hmm.
in the walls.
Yeah.
And it made a difference.
It does.
But
yeah.
they leaked like crazy.
Mm-hmm.
So review the 5 principles. Did we make it through 5 or is there still one?
We did.
Okay.
So high level of insulation, avoiding thermal bridging, good quality windows, air sealing, so air tightness, and heat recovery, filtered air supply.
Okay. So why should my wife want to live in a passive home?
The level of comfort and air quality is superior to any code-built structure and any other Energy Star or Zero Energy Ready home or other green building structure. It's for the comfort, for the air quality, and for the resiliency, the ability to withstand sudden changes in the exterior environment without really being fazed by it.
I think she just bought. That is. We've been doing this 25 years, and there's so many nuances of what's important to our custom home clients, and allergies, dryness,
Mm-hmm.
fresh air. They want to make sure they're getting, it's important. And
Mhm.
so it's, okay, sometimes in these houses we can do partial
Mhm.
passive
Mhm.
things. Sometimes it's hard to meet the gold standard, which
Yeah.
is, the International Passive House.
Mhm.
But I think that so many builders can do more in their custom builds to help improve the homes that we're building, and our clients sometimes don't even understand.
Mhm.
But this is what you're going to get: better air quality, more comfort.
Mhm.
Those are key.
And just to give you an idea, this is a conversation I actually had this morning on a client call about a retrofit in Boulder.
Okay.
True story.
Yeah.
I was just giving them, this is something that we do. We do the analysis at the early stage of the design, kind of a way to help clients understand budget decisions, because
Yeah.
every project has a budget, and prioritize what they need to do, because sometimes they don't have the budget to do the full passive house. the priority list we gave them was try to air seal and vent properly so that you get the air quality and the durability from the building. That is pretty low-hanging fruit.
Yes, it is.
Then step up also in cost, but it does pay back in terms of comfort a lot, is upgrade windows and exterior doors. Going from a code minimum set of windows to a passive house level windows is an incredible improvement in terms of thermal comfort. And then what is left is the amount of insulation that you use. Assuming that you go with some, at least code minimum, but you have the other pieces, you end up with a good quality building. Increasing the level of insulation improves your energy efficiency, but the other pieces that I mentioned, the pressure ventilation, the ERV, and the air sealing, gets you the air quality and the durability, and the window package gets you the thermal comfort. So there's a lot. Of course, they also get you the energy efficiency, but there's more value per dollar spent.
Yes.
Does that make sense?
Absolutely.
It's a way to prioritize that strategy.
And a high name brand window doesn't mean it meets passive standards.
For my personal house, I priced out 20 different manufacturers.
Yes.
Because why not? And my house is at 8,800 feet of elevation. So high up, cold, very cold, near Winter Park, near Fraser. Yeah. And the funny thing is that the 2 or 3 most expensive windows that I priced out don't even come, all triple pane, don't even come close to the thermal goals or the thermal comfort goals of passive. So there's a lot of dollars, and with the triple pane, but they very much underperform, even if they're the most expensive. So dollar amount doesn't always equal performance.
That's correct.
Yeah.
And that's something, some people will get stuck in their selections on brand awareness, brand, how the company is received in the market, but really it doesn't always pay.
Correct.
So I think that's something important, as you consider building passive, is you got to look at pricing the whole package. And that's what, you've been able to do with some projects for us. And I just think, it's a brilliant service. So Enrico, another question, speaking of passive, and my wife, and unfortunately she's allergic to Colorado. Every single tree. Well, I mean, I got air purifiers in, it's not a home I built. It's, it's a remodeled home, and it doesn't meet any passive standards or even passive adjacent. But tell us about indoor air quality improvements in this new environment that we've created by air sealing and tightening everything down. Why is that good for the consumer?
So I can start with the story of us, my family, living in a house in Denver that is built to code. It is less than 10 years old. It's pretty new, relatively speaking. And I have the habit of buying new air quality sensors to try things out. I have a CO2 monitor in our primary bedroom. I have a radon monitor in the baby's bedroom, which is on the main level over the crawl space. And then I have a particulate matter sensor in the living room.
What kind of sensor?
PM 2.5. It's particulate matter.
Yes.
So these are 3 different metrics we use to evaluate air quality, and they each look at different forms of pollution. Radon is a type of gas that is natural and it causes cancer, so pretty bad. Particulate matter is microparticles that we produce cooking, and they also cause cancer. And then CO2 is not a form of pollution itself. It's just an indicator to see how stale the air is.
Yeah.
And in the shoulder seasons, it's not that bad. We keep the windows open-ish. We get pollution from the outside, but at least we can get rid of the pollution we produce inside. Now that the AC is on, we don't open windows as much, so we have a lot of CO2 in the primary bedroom by just sleeping. So the air is pretty stuffy just by us consuming the air overnight, because the AC just recirculates. It's a very standard recirc, so it doesn't provide any fresh air. In the kitchen, I have the particular method, and I can go back weeks, and I can tell you exactly what time we cooked because I see spikes of that.
What are you cooking?
Food. No, it's like nothing fancy, but just like cooking any kind of food, it produces particular method which causes cancer. And then in the kids' bedroom, I have the radon sensor, and I spent a few weekends last year air sealing the crawl space, but the unit, the AC is in the crawl space, so all the air gets recirculated, and even if it is sort of decent down there, it still gets a lot of radon up. And Passive House concept of air sealing very tightly the building and then providing a continuous supply of filtered fresh air kind of takes these pollutants away and replaces them with fresh air. So it's a different concept which really prioritizes air quality. It would remove the CO2, it will remove the radon, and will remove the pollution from cooking, the particulate matter. So it will be a different style of living.
Because you're encapsulating the building envelope, you're removing, it's continuous to above the soil, so that locks it in. Do you have a mitigation system at your house? Is it a passive radon?
There's a passive radon system, but it's not really working very well.
Okay.
Yeah.
So you might need to go active and add a fan to it.
Yeah.
But no, I think that air quality is, so important. Air quality, insulation. With the insulation, spray foam versus another type of insulation. Talk to me about what your thoughts are.
So we try, as consultants, to spec products that will, in our opinion, will deliver what they say they will. And our experience back in Europe with spray foam is that the rating, the R value that you get for every inch is about half of what is labeled value here.
So if I get an R7 per inch, you think I'm only getting an R3.6? Yeah.
Yes.
Okay.
Yeah. So big gap on the performance side. And then there's plenty of buildings that have been air sealed with spray foam where the foam shrinks and cracks, and after a few years they leak.
Okay. So
the air seal is not really there. So we use spray foam in very specific applications, such as once the window is installed, we have a gap all around it. We fill that gap with spray foam or some other types of insulation if somebody doesn't want to have spray foam. But that is an application I can see the use for spray foam, not as an air sealant, just to insulate that gap. It's very important from a thermal performance of the window for that gap to be insulated. And spray foam, it works very well in that case, but it will not air seal because it will shrink. But that is our experience with spray foam.
What about the good and bad of the types of insulin for our environment? Do you have a thought on that?
I do. It often comes down to the expectation of life of the building. As a European, I try to design buildings that will last 50 or 100 years. So that is kind of the mind frame I go into when we specify products. There are products that are more carbon intensive, like spray foam is one of them. Foam is EPS or XPS specifically is very carbon intensive, as opposed to cellulose fiber or wood fiber board or hemp that are much more friendly or less embodied carbon. And I like all kind of products. Like we work with, other than asbestos, we try to kind of see.
Please, no asbestos.
Yeah, no, that's a joke. We try, like we're brand neutral. We try to understand the durability that we can expect.
Okay.
I love blown in, and I love loose fill because of we do a lot of double stud walls. We do a lot of attic insulation. And we do a lot of 20 inches of that insulation, please, or 24. So we do a lot of insulation.
Yeah.
So loose fill is cheaper. It's faster to install. It's easy to install. So
it's more cost effective.
Yes.
Yeah.
Yeah.
Than the spray foam. 'Cause, I'll run across clients every once in a while that were retrofitting an older home and to meet the R values that are required without building, turning that old 2x4 wall, because nobody wants to lose real estate and go in 8 more inches or whatever to frame in another wall, but they don't like the spray foam. So sometimes there's these challenges that we got to solve for, find alternative spray foams that are more green, less carbon intensive.
Well, I'll challenge you that statement. Something that my experience is oftentimes you can avoid compliance through typical compliance is just going to a prescriptive method. A more advanced way to do it, and it can be cheaper, is going to a performance path.
Yeah.
Where you can demonstrate.
Model it.
And
like a home energy rating system.
Exactly.
Yeah.
And that is a way to show the city that, hey, if you don't add insulation but get better windows, you get better comfort, or maybe you air seal better, you get better comfort, you get better efficiency without losing that real estate.
Yeah.
So it's kind of addressing that in a kind of a smarter way.
What do you think about the exterior rated or exterior sheeting with an insulation on it?
I have, from a carpentry standpoint, if you're talking about the Zip R.
Yes. The Zip system is the most common right now. I know there's LP has a system now.
Yeah.
I mean, it's pretty great for a continuous insulation, which helps with that building envelope.
Yeah. So from a thermal standpoint, it's good because it adds continuous insulation. If you're trying to use the sheeting as your air barrier, it is on the wrong side.
Okay.
Because in our climate, we want the air barrier to be warm because it is cold most of the time, so you want to prevent condensation. And so I would love the Zip to be flipped and the insulation being on the outside, which would make also structural engineers happy.
Yes.
We don't use it a lot for a number of reasons. For most of our projects, we do more than 2 inches of insulation, so we need more insulation that both Zip can or similar products can provide. And then the air barrier, we do the regular Zip panel as the air barrier, and then we add insulation on the exterior if that is an option.
Yeah.
Yeah.
Because then, you add 6 inches of insulation.
Yes.
Then the architect wants siding.
Yeah.
I mean, it's always just new challenges. What are the attachments? How long are the screws to get through?
So there is a practical limit to the board, or at least yet. But you could, if you're going with that amount of insulation, you can frame something on the outside and attach to it. Like for my house, I need a lot of insulation because I'm high in the mountains. I'm attaching 16-inch I-joists on the outside of my 2x6 wall, and then specking that with just blown-in insulation.
Okay.
Pretty quick, ton of like an R80, like ridiculous. I don't even
way
need,
too much. No,
I don't even, literally. I'm in the mountains at 8,800 feet of elevation. I'm past passive house, but this is the time that is cheapest to add insulation, and it builds so much resiliency that the building is going to be very unfazed by any changes from the outside. So that is where I see the value in having so much insulation. Don't do that at home. Have someone to actually calculate how much insulation you need. I just went for the biggest that I could get.
Yeah, cool.
Yeah.
Thank you for listening to Built by Insights. I'm Matt Krueger. This is the second of 3 episodes featuring Enrico from Emu Passive. Find more info about Enrico and passive houses at emupassive.com. Our next episode with him discusses the challenges and benefits of building a passive house. More podcast info at builtbyinsights.com.